1. Here we go. And we are currently live. Hello, everyone, and welcome to our 7th podcast episode. My name is Quentin Anderson, and I am the host for Real Time Talk with Eagle 3D Streaming. We have an insane podcast today with the one and only Maurizio Sciglio. For those who are not familiar with Maurizio, for the last 4 years, he has taken on a variety of positions at Epic Games, including Director of Media Services, Studio Director, and now he is the Director of Unreal Cloud Partnerships. And as we will see today, and why I am very excited to have him on the show, one of the projects that he has been involved in, even before Epic Games, is now what we refer to as pixel streaming. So yes, folks, we get to dive into the wonderful and deep history of pixel streaming today. I met Maurizio in 2020 over our mutual interest and fascination and love with pixel streaming. We've hit it off since then, and now it's grown into a nice collaborative partnership. Maurizio, how are you doing today?
I'm good, thank you. Hello, everybody. Thanks for having me. Looking forward to this.
Yes, and thank you, Maurizio, for taking time out of your very busy schedule for us to just have a little chat around pixel streaming. Before we get into it, for all our new viewers today, here is how the podcast format works. So as you know, our shows are totally live. I mean, we're in the real-time industry, right, Maurizio? We gotta keep it real time. Which means that during the show, we encourage participation. And if you have any questions based on what Maurizio and I are discussing, please feel free to share them. We love interaction, and we just want to provide information that's relevant to our viewers. So with that being said, we can go ahead and get started with a little discussion. And Maurizio, if you wouldn't mind, can you just share a little bit about your current role and responsibilities within Epic Games?
Of course, yes. So as you mentioned, I'm the director for cloud partnerships. So basically my role and my team, we work with the rest of the organization to kind of drive the overall cloud vision for Unreal Engine in the cloud. So we work closely with the engine team and engineering and product teams. But also we have a business development function, so we can work with companies like Eagle 3D, of course, and make things happen, really. And the way we see partners is very much like partners for us are kind of allies. It's not just a way of like go to market. It's more like how do we build, how do we change the industry, how do we move the industry forward together by, again, building exciting solutions like pixel streaming and other technologies. So that's, in a nutshell, that's what I do. I help the company drive the overall Unreal Engine cloud vision.
Mm. Yeah, and so if we kind of break it down a little bit between content creation and content consumption, what are some of the initiatives that come to mind when we think of content creation, when we think about the cloud?
Yeah, so I think it's an interesting space, kind of accelerated by COVID. So I think what we learned from COVID is like the old way of working, where you download a piece of software, just use it locally and within the same office. That's probably not going to happen. Never going to happen again. Not like full on premises anymore. I think we like starting from COVID, and I think going forward, we're going to see more of kind of a hybrid scenarios where some people might work from an office, some people might be working from home, and some people might have fast computers to use Unreal Engine locally. But some people might just might be traveling, and they might need a workstation somewhere. Mm-hmm. And I think that's where cloud can help generally. Accessibility, I think, is the key word here. Like a cloud environment will enable that level of accessibility that you need, and you will be able to work from any location. So from a content creation perspective, I think that's a fascinating future where you work from any location, and you can still collaborate with your friends and your colleagues, and so that I think that's going to be definitely, like, cloud is going to play an important role when it comes to content creation. And like, imagine a future where you're starting a company and you don't have enough funding, you don't want, or you just don't want to spend enough too much money before you validate your idea. So imagine being able to just subscribe to a service, and straight away you got everything that a real life studio needs, from like workstations to continuous integration, build farm, and content processing, all available in the cloud with no skill set needed. No need to have like an a super specialized IT expert. No need to install like a complex version control system. It all just works. It's all optimally configured for you. You just subscribe, and then you're productive from the get-go. That's a sort of like the way we are thinking about potentially content creation. And it doesn't need to be necessarily full cloud. It can be a hybrid model where, again, maybe, Quentin, you have a powerful workstation. Maybe I'm traveling and don't have access to a powerful workstation, so I use the cloud, and you use a local machine, but we're still all kind of rely on an infrastructure running in the cloud. And so that's the kind of the content creation side of things. But kind of a natural extension to that model is content consumption from the cloud as well. Once you have your data and your studio already running in the cloud, as a natural extension, why do you need to download binaries? Why do you need to download and install executable? You might as well stream them from the cloud using Pixel streaming. Like, imagine, like, you want to test a build I just created. No need to download gigabytes of data. You just go to a browser and start streaming straight away the latest and greatest build.
And for those who are maybe a little bit newer to the term pixel streaming, what is the difference when I pixel stream an Unreal build versus when I run it locally on my desktop? What are some of the benefits that I'm afforded by doing that?
Yeah, so the definition is like, the latter is essentially all like what we used to do until literally now. So if you want to run an application on your computer, what do? You download it, you install it. If you're running on Windows, there is an executable, and then you launch the executable, and that application is going to use local resources. So if you're trying to run Unreal or any real-time application, you need a fast GPU. You need to have a decent CPU and like a reasonable amount of memory, both video memory and system memory. What we're calling pixel streaming, maybe I should clarify the term as well. So what we call pixel streaming, in a nutshell, is an interactive movie, like a zero latency interactive movie. It's the same technology behind Netflix, to keep it simple. The difference is the application is running in the cloud. So there is and again, the definition of cloud here is someone else's infrastructure, really, in a nutshell. So there is a computer running somewhere, public cloud or private cloud, and that machine still needs to have a GPU. So you run the application there, and then what we do behind the scenes, we encode a video, like an H.264 video or VP9, depending on which version you use, and then that video is sent back to your browser. And your browser is just, again, a video player at that point, with the ability to capture inputs and send inputs to the remote machine. So again, very much kind of a very low latency interactive movie. That's the definition of pixel streaming. And to answer your question, what's the advantage? Of course, the main advantage is accessibility. You don't need to have a powerful computer. We're talking about playing a video, so any device capable of decoding a video, which is literally everything, is virtually capable of running such a technology. So zero barrier to entry, no need to install anything. As long as you have a browser, you can run very high quality interactive applications.
And you're certainly no newbie to pixel streaming. You actually had quite a bit of a hand in developing what is now known as the pixel streaming technology. Can you take us back to the early days and maybe shed some light on where this all came from and just sort of the
Yeah.
background and history of how this played out?
Yeah, of course. Yeah. So it all started, I think, in early 2018 from an Epic perspective. So at that point, Epic, a couple of months before that, Epic acquired my my startup, CloudGen, and there was a need from an Epic perspective to do what I just described, run an application in the cloud and make that application accessible from any location with no installs needed. So we started looking into this space, and we built this technology, Pixel Streaming. So that wasn't the first time that we built. My team again built such a technology. So the technology itself goes back a few years earlier than that. 2012, when my co-founder and I, like in the early days of our startup, decided to put a prototype together. Completely different use case back then. We weren't thinking about super high quality car configurators or even games. The Actually, the interesting thing, like we started like the application back then was more for like kind of a touristic application. Like imagine going to an old place. We're based in Scotland, so there are lots of like old cathedral in a. And imagine being able to go to that location with your iPad and being able to see how like those cathedrals used to look like back in the days with super high quality, super high rendering quality. And back then, again, 2012, the like devices weren't fast enough, nowhere near fast enough to do proper high quality real time rendering. So the technology that we ended up calling Pixel Streaming was meant to solve that sort of problem, and offer a backend for an iPad or like a mobile device or a tablet to deliver super high quality content, and real time rendering. So yeah, and that was an interesting project back then.
Yeah, and that was 2012. I mean, I couldn't even wrap my head around cloud streaming at that point. And so one of your first applications was actually providing sort of a backend so you could have high fidelity graphics to an iPad, because we just knew that there's no way you could locally render those high fidelity graphics on an iPad. I mean, you couldn't back then, and you still can't today. So that was sort of, I guess, the impetus, or where the idea came from. And then how did it go from there? Was it shared with people, or?
Yeah. And to be clear, we didn't invent the technology. We wrote the technology, but it was heavily inspired by OnLive and Gaikai. Back then, like those companies had been around for many years. So the concept was well understood back then, but again, we approached it from a different angle. And so back then, again, I remember showing a demo. Like we always been very close, even as a startup. We were close to Epic, and we were using Unreal Engine our technology was engine agnostic, but we were good friends with Epic. And I remember showing the early prototype of the technology to Epic, Tim Sweeney and Epic. Yeah. So and then we kind of changed a little bit. So back then, 2012, 2013, the technology wasn't really ready. Like pixel streaming as a technology is quite simple, but the challenges are, as you all know very well, challenges are making it viable, making it scale and making it viable, in terms of like scaling capacity. Are there enough GPUs in the cloud, and are they affordable enough? Can you actually build something and make it work financially? So the answer back in 2012 and 2013 was no to both questions. So we decided to change our focus as a company, as CloudGen, a little bit more towards still cloud, very much cloud, but more towards like the simulation side of things. And My background back then was I'd been working in video games for many, many years, mainly multiplayer games. So I was acutely aware of like the challenges facing that you would face building a multiplayer game, making a multiplayer game scale.
Mm.
So we decided to essentially build a technology that would use the power of the cloud, all the resources available in a cloud environment to kind of supercharge the experience, make physics simulations more scalable and more and more accurate in a way, and the same AI simulation and so on and so forth. So we've been kind of like moved away from pixel streaming, focus on simulation. And then when we joined Epic, as I mentioned before, there was this need to deliver a super high quality experience and Unreal Engine application from a cloud environment. So we went back to the cloud rendering model.
Mm. And was that need for the Metahuman project, or were there other needs, or how did the marriage of pixel streaming and Metahuman happen?
Yeah, so that was much earlier than MetaHuman. So that was the main driver was enterprise applications back then,
Mm-hmm.
namely, again, as I mentioned before, car configurators and architecture visualizations. I think those were the two main driving forces for pixel streaming.
Mm.
The marriage between MetaHuman and pixel streaming happened much later.
Mm.
Try to remember when we started working on it. Almost 2 years ago, a little bit less than 2 years ago, a year and a half ago, maybe, when the main application, actually, the main team driving MetaHuman has been Trilateral, one of the acquisitions from Epic. So they own it. Well, they have the expertise. They build the technology, and they needed to deliver it to a browser. That's when we started engaging, and that's when we started thinking about, okay, pixel streaming is a good match, it's a good fit for it. And at that point, yeah, we started working together.
Mm. And then just having a role in pixel streaming, and also, of course, the MetaHuman project, or pixel streaming MetaHumans. When you think about some of the challenges or limitations when using pixel streaming for production level projects, what comes to mind, or what should we be thinking about or considering?
Yeah, so a few things there. Like there are some technical limitations. Like you're talking about running an application somewhere else with a network in the middle.
Mm-hmm.
So distance, there is some latency that you need to take into account. Pixel streaming is not necessarily suitable for every single use case and every single application. If you're trying to deliver something that can't tolerate any latency, maybe pixel streaming is not for you. Something to take into account again is definitely you need to have data centers as close as possible to you, to the user, because speed of light, there's nothing you can do there. The closer you are, the better experience you would have as a customer. Also, performance of the application really matters. So related to latency, latency is made of multiple components. As I mentioned, network is one of them, one of the contributors to latency. But the frame rate is another big one. If your application is running at 30 frames per second, you're talking about 33 milliseconds simulation step. That is the latency routing. My definition of latency, I should clarify, is the time between you clicking on a button on your local computer and you observing a change on your monitor. Before that happens, you need to send your input from your browser to the server, and there's a network in the middle. That's one element of the latency. Then you're injecting your input into the simulation to the application, and then there is a simulation step. You need to wait for the engine, for the application to render the current frame. That is the frame rate I was referring to. That's kind of the additional latency introduced by the simulation step itself. Then you need to encode into like H.264 or VP9. That's an additional latency. then send it back to the client network, more latency, and then decoding on your local browser, another component for your latency. So running at high frame rate is very important because you minimize that simulation step, that simulation latency that you have. Something else to take into account is, of course, capacity. You need to make sure you have enough GPUs to serve your customers, and cost. So that's definitely another challenge. GPUs in the cloud are still very expensive, so that's something that needs to be taken into consideration when designing a Pixel streaming solution.
So if we think about capacity, think about cost, and then also latency, do any use cases come to mind that may be suited for pixel streaming? Just sort of us knowing where the limitations and where the technology currently stands today?
Interesting one. So from a user perspective, I think any application where latency is not a big issue, again, maybe architecture visualization or car configurator are good examples. Like, you don't need to optimize for a single millisecond. Like, especially if you design the application, the user interface in the right way, you can get away with a slightly higher frame rate. That's from a latency perspective. From a cost perspective, the best case scenario. So the cost is, of course, like the main contributor to the cost is the number of GPUs you use. So what you would want to do, like the way to optimize that, is either reuse the same machine, like try to run multiple instances on the same machine. So if you can serve multiple users from the same GPU, that's a win, of course. You're just dividing the cost by the number of users you're serving on a single GPU. But also you can be more creative. If your application allows you to do so, maybe you can share the same viewport across multiple. You just run a single process and then you share the same viewport. Like, maybe you have a predefined number of cameras in your environment, and then you effectively broadcast a single camera viewpoint to multiple users. So you're not wasting GPU cycles for every single user you have. Like, you're basically absorbing the cost by minimizing the number of viewports. So those are kind of some ideas to make pixel streaming a little bit more financially viable, I would say.
And is there a if we're working with the public cloud, is there an operating cost for using Microsoft Windows? Is there a licensing fee? And what are your thoughts around Windows versus Linux in the cloud today versus the future? What do you think?
Yeah, so the answer is definitely yes. It's the same across all the cloud providers. So Linux is cheaper than Windows for the reason you just mentioned. There is a licensing cost per core, I believe, associated with Windows. So there is definitely like a major cost saving by using Linux. And that's something actually we're trying to do internally within Epic. Our workloads, Metahuman, Twinmotion, are running on Windows because the application itself relies on some features which are only available on Windows, ray tracing specifically for Metahuman. But there is definitely a big push from our side to better support Linux. Because Linux, for a couple of reasons, actually. First reason you already mentioned, cost. You probably save, depending on virtual machine types and cloud provider, you can probably save around between 30 and 40% of your cost just by migrating to Linux. But also, when you think about cloud and cloud infrastructures, it's Linux. Linux is the de facto standard for this kind of technologies for cloud solutions. So being able to run on Linux means you can get access to like decades of knowledge base and skill set and technologies as well, which are just not available on Windows. And that's the reason why you might have noticed as part of our Unreal Engine 427, we announced support for pixel streaming on Linux and support for containers in Unreal Engine 4. So we're trying to build all the foundational tech that will allow Unreal to work on Linux in the future.
Yeah,
and you'll see more effort in that direction.
So if we then think about the future, how do you imagine Unreal Engine being part of a complex cloud ecosystem? What do you think that's going to look like?
Yeah, so cloud solutions are usually based on lots of components talking to each other, like lots of interop. And the way we are imagining Unreal Engine in the cloud, we want Unreal to be, as you kind of mentioned, we want to be a first-class citizen in a cloud environment. What I mean by that is Unreal Engine has to be able to interoperate with other standard cloud technologies in a cloud environment. Again, containers is a good example, like being able to run Unreal Engine in a scalable way as a container within a Kubernetes cluster, as an example. Or even just things like delivering a Unreal Engine in a way where you can use it beyond the traditional content creation and content consumption we described before. Maybe as a simulation engine. Maybe you run it to power and to generate training data for machine learning. Imagine being able to reproduce like a very realistic city or urban environment and use the data generated by Unreal Engine and its super high quality rendering just to train a model for self-driving cars, and as an example. There's so many examples. So you want Unreal Engine to be a component within a much complex architecture.
And I think it was, or I don't know if it was Elon or who said it, but the way that we will train or use machine learning is also through machine learning simulations rather than real world physical data. So do you think Unreal Engine will also play a part in those types of simulations?
Oh, yes. I mean, there was definitely a lot of it, like the big adoption from that space as well. Definitely Unreal Engine is being used for machine learning as well. I mean, if you think about it, it makes sense, right? Like if you want to train a self-driving car model, it's about amount of data that you generate. Yes, you can send your car driving around and have a dashboard camera and sensors to capture the environment. But how do you simulate extreme situations? Like someone is crossing the road and like a real-time engine, like a virtual engine, kind of a digital twins, whatever you want to call it, will allow you to generate data much quicker and simulate scenarios which are not really possible in real life.
Right. Yeah. So it's almost simulating real-world phenomena in a virtual environment to make it more cost-effective, more accessible, easier to control. That's a really fascinating application. So do you imagine the pieces of the cloud, will it be more of a hybrid setup where there will still be some instances where we're still working locally and then we'll just use the cloud for certain applications? Or how do you think it'll be more of a hybrid setup, or are we going to be mostly in the cloud in the future? Or who knows?
Short, medium term, definitely hybrid. I don't see like 100% cloud future, at least in the next 5 years. That's my personal opinion. So it's going to be a hybrid model, maybe similar to what I described before. And initially, I think cloud would benefit content creation first and foremost, like being able to produce content and generate content using Unreal, using other creation technologies in a cloud or no matter where you are. I think in the future there are also potentially interesting applications of cloud, which is again what my company was exploring back in the day. Maybe we can actually parallelize the engine. Maybe we can modify engines to be more effective in the cloud and actually leverage the additional power you have in the cloud to do some much more complex simulations and go crazy when it comes to simulating environments and simulating physics, AI, and scale up. Of course, that will come with a significant additional cost, but there are some interesting use cases enabled by that.
Yeah, and I guess we cannot go through this entire show without talking about the M word, metaverse. So any thoughts on metaverse and cloud and for our users or and our viewers?
Oh, that's probably another couple of hours about that.
I know.
Like metaverse, at the end of the day, I think there are too many angles, right? One angle, I mean, we already kind of discussed is content creation. Like metaverse will need an absurd amount of content, and cloud will definitely play a key role in accelerating that creation of content.
Mhm.
That's one way of doing it. Yeah, so it we can talk forever, really.
Yeah, that's another 10 podcasts.
Yeah.
Well, we are at the half or at the end of the hour. It came upon us quick, and I know you've got to hop off to get into another meeting. Thank you, Maurizio, so much for joining us today to explore the history of pixel streaming and Unreal in the cloud in general. Everyone, we have a new feature coming out next Friday, so be on the lookout for that. Maurizio, thank you so much for being
Thank
part
you.
of our show.
Pleasure.
And we will catch everyone on the next show. This is Quentin Anderson with Real Time Talk with Eagle 3D Streaming.